So we're going to continue the session one more hour, and then we'll have lunch. I have put a paper, a sheet on your seat. It's an evaluation form. It would be nice if you'd fill it in and give it to me before leaving the room. That would be really nice. We're going to continue now, and I think that Paul's presentation was a very nice transition to what we're going to hear now from the next presenters, because he already introduced some of the terminology that we're going to hear more about with the presentation of Shenghui and Rob, Annapaola, and Thom. So, Shenghui, please.
Yeah, thank you, teacher. I'm Shenghui Wang from the OCLC. I'm a research scientist here, but now it's the time to talk about some deep interactions with open collection. At least our attempt to have some deep interactions. So we have 4 presenters here in this session, including me. We are all part of this CatVis project, visual analytics for the world's library data. For a couple of years, we have been working together, try to use visualization tools to show more value, try to show more value of the library data. This is a collaboration between Technical University Eindhoven, University Amsterdam, and us, OCLC Research. In this hour, we will focus more on one particular workflow of for the digital humanity researchers. They start with questions and then try to collect some corpus and do some data cleaning, and for using semantic embedding, try to extract more semantics from the textual data. And of course, in our project, we do data visualization, try to see whether we can use visualization tools to help the digital humanities researchers to answer their questions better or faster. So I will quickly give the floor to Annapaola, because she is the philosopher who has the questions.
Thank you very much. Yeah, so my name is Annapaola Ginammi. I'm a postdoc researcher in philosophy at the University of Amsterdam. And yeah, I will tell a bit about like our experience as a user, as like philosophy researchers. So yeah, just to introduce the research group that I'm part of, it's called the Concepts in Motion group. Our specialization is history of philosophy of science, roughly from like the 18th century to the 20th century. We have a history of ideas approach. So we try to trace like shifts of meaning in philosophical concepts, concepts like truth, consequence, number, life. So we want to see like how these concepts developed. And yeah, we are trying to take the computational turn. Because philosophy, as it is traditionally done, like involves a lot of like close reading, very close reading, analysis of very limited sets of data. So some philosophers spend their entire career just studying the works of one philosopher. And we are trying to scale that up to make this history of ideas approach possible, to trace larger amounts of works through a larger time span. But actually we face a major challenge, and that is the lack of existing high quality and easily accessible corpora. So what kind of corpora do we need? So multi-language, multi-scripts, books and articles from different historical periods. Very hysterical. Yeah, so we study mainly German philosophers, but also English ones, Polish ones, philosophers that wrote in Latin and in Greek. Many of the German texts that we study are written in this Gothic typeface in Fraktur. So yeah, that's already a very diverse corpora, and we study both like major philosophers, very well-known ones, as also minor ones. And some of them are, for example, Kant is very well known, Bolzano already a bit less, Frege, Russell, and Quine. And ideally, we want to study all their works. If we want to know, for example, like what is the concept of truth that Bolzano had, we want to be able to study like all his works. And the problem is that the works of these philosophers are often scattered among different repositories, for example, Google Books, HTTrust, or Europeana. And the only thing that can be downloaded are like low quality scans, PDF images of original printings in Gothic typefaces. So that makes it hard. So what are our quality requirements? So what are the formats that we need in our research? So yeah, we like to be able to use like text mining tools, distributional semantics, machine learning techniques. We like to explore like the possibilities of applying those methods. So the very minimal requirement we have for our text is just to have plain text. It would be better to have like TEI format, which is like this text encoding initiative. So it's the plain text plus some structural information. And even better is the TEI of the Deutsches Textarchiv, which is really a subset of the text specialized for historical texts. But ideally, because we are like studying a lot of like mathematical text, philosophy of mathematics, logic, so there are a lot of formulae in that. So ideally, we want also the faithful renditions of those formulae, and if possible, also linguistic text, but that is like really very far in the future for now. So the corpus building, Rob is gonna take over.
Okay, then she has a list of works, and it's not really metadata they just have a list of these books we want to have scanned. So my task was to see whether there are some open sources available to scan those books, to find those books. Obvious is the Internet Archive. There's a ton of information there. The HathiTrust, also a nice data set. There's also more obscure books, HathiTrust, and Google Books, of course. So, Internet Archive. This is one example, Wissenschaftslehre. I think you could translate it to science. As you can see, it's all Fraktur. If you can see it, you have a lot of choices, so you feel very happy. Unless you look at it. I don't know whether you can even read this. I guess with a lot of AI you could turn it into something. Oops. So what about it? Searching is okay, but always slow. And there's a problem because the metadata is not so good. So if you want to find something, you have to look into it in multiple ways. Normally, I would just look for the author and one like Bolzano, and then say everything between those 2 year ranges and do a very fuzzy match. Then you find out that not all works of Bolzano are so popular and scanned. So you find only a fraction of the total. And if you find something, you have to find the one with the best text. My clicker. Then you go to HathiTrust and you feel a lot happier because you have more heads. The data is much cleaner, so it's much easier to find things. So then you have this problem. It's totally open source, so everyone should have access. And even the HathiTrust libraries agree that everyone should have access. So you look at, and it said the use of material in HathiTrust may be defined by third-party agreements. For instance, libraries agreement with Google require us to take steps to prevent bulk download. Means no luck. Then we go to Google Books, and then we find out, they have a very nice API. Their metadata is quite nice, and their text, the underlying texts are much better. It looks like that Google is silently improving their Fraktur reading and all those things. The API, when I did it, was it could do 1,000 queries a day unless you pay, and now it says they decide how many queries you can do in a day, and you should not circumvent it. The API for looking for public material is free, so you should, in theory, don't need an account, but still I took an account, because if you don't have an account, they randomly don't reply. So they're throttling it, but it's not clear why and how. So I was not very happy. The good news is all those things have APIs, and all have different APIs. And like the archive, sometimes the API is very complicated. In Google, sometimes the API is very easy. But each source has a different API, which makes it very expensive to go to this data set. And you cannot get as much data as you want, and there's no standards for metadata and lacking. So discovery is very fuzzy. So what you do, you find everything, and then you do a very fuzzy matching and find the best match. So that's the same idea about data quality in general. But both precision is low and recall is low because, yeah, sometimes more text, sometimes less text, and sometimes text is totally missing. And if you look with the wrong query, then you have no results, you don't know why. And I think the OCR varies a lot, and the text layer is not always okay. So I had to tell them no luck.
Thank you. Yeah, so that was the situation, and of course we wanted to do our research anyway. So yeah, what are the solutions that we found? The first of them was to have our books professionally OCR'd and corrected by a company, which is about €1 per page, and we have high quality TXT with about, like the OCR is about 99% accuracy. So that means every 100 words we have a word which is not correct. That's a lot for philosophers. Yes, I mean we are doing very like to apply the text very well. Like these meanings are very important. So if the words get not recognized correctly, then we have a problem. So yeah, another solution is the cooperation with the Deutsches Textarchiv, like the ones that have the format that works very well for us, like specifically for historical text. And yeah, they have a lot of German text online, openly accessible, but only very few of the ones that we are interested in. So yeah, we are trying to start a cooperation with them so that we pay some money to have our text processed in their procedure and then put online and made openly accessible. But then we have to pay still €3 per page, and they outsource the process, and then we obtain a text like with shortcuts in their XML. So then we have to do a lot of manual work still to obtain the right structural information. So that is the story. So also that is not ideal. And yeah, to give an idea, like for example, for Bolzano, we have a large part of his works, and that's about 11,000 pages. So yeah, we're talking about a lot of money for us. So yes. So yeah, the first route that we follow. So if we obtain high quality TXT, what do we have then? So we obtained folders containing the OCR scans of the printed material, both in déjà vu and in TXT format. And all those files corresponded either to a book or to a section of a book. And the file names were completely non-mnemonic, so we had to look every time at the files, look at the document itself, see which book it was, because yeah, it was not we were not able, if we had a book in mind, to just open the right file immediately. And the files contained a lot of peritextual elements like title pages, editors, prefaces, and multiple sets of notes, both of the author itself and of the editor. And yeah, so we know, like from our philosophical work, that ideally we would like to have like paragraphs as the units of text analysis, but like these files had no paragraph markers, so we had to segment on sentence level. But also that was quite problematic. So yeah, cleaning the data to be able to apply some tools. We had to segment on sentence level, and we had this basic approach. So a sentence is anything between two periods. Well, then we had many false positives. For example, abbreviations. In German, und so weiter, US, every time with a period. Abbreviations of publication titles, reference conventions, and many other problems. So we obtained, like, very many false positives. And it looks like this, for example. This is 2 pages from a book from Bolzano. And then, for example, does the pointer work? Yes. Then we look at this part, like here a sentence starts, then we have here a footnote, and the sentence ends here on this page. So zoomed in like this, the sentence starts, here, and then goes on until here. And that looks like this in the TXT file. So we obtained, like 9 different sentences from segmenting on sentence level by just looking at the periods. Well, this is unacceptable. Of course, we cannot apply any computational tools on this. So, yeah, because here we have like periods. We have like this peritextual elements, like this horizontal sign, vertical sign, which was a marker for, like in the original text of Bolzano, that was where a page ended or something like that. And then the footnote, which was on the bottom of the page, comes in the middle of the text. So then, luckily, Shenghui helped us and did some semi-manual cleaning to get the results more acceptable. So, like she removed, for example, after the page number indication, the dots. If there was like a single letter in an author name, like this one, she removed the dots, and also in the abbreviations. So what we obtained then was already much better. So at least we have one sentence here. But yeah, of course, we have still the footnote in the middle, and we have still a page number. But at least, this is something that we could, in theory, work with. Okay, and then, to get things even better, we would like to have, like, the editorial insertions removed, also the page numbers, and, like, the footnotes delimited, so not in the middle of some sentence where it happened to occur, like in the original book, but really marked as being a footnote. And also, remove hyphenation and, like, to glue the words which were split up together again. So this would be the desired result, with just here the sentence, and then here the footnote, and also with some kind of footnote marker that we know that was a footnote. So the problems that we encountered here, there were, like I said, the editorial markers. Also, like in the source text, they were in superscript, but not in the OCR file. They were sometimes just part of the normal text. Some editorial insertions, such as angled brackets, were not recognized and just replaced with other signs. And also, like we as philosophers, we want to be able to see when an insertion is done by an editor or when it is something like what belonged to the original text. So actually, like the removal of the editorial markers is only in order if we are also able to go back to the source file. So from the computational tool that we have, go back to the source file immediately to see like whether something was indeed part of the original text, yes or no. So the moral of the story is that for us, like even perfect OCR is not good enough. We really need some structure. And yeah, we of course, as a group of philosophers, we cannot do that ourselves. So we need other people to do that for us. And now Shenghui will go on again.
Okay. Now we're talking about something a bit distant from philosophy. It's about semantic embedding. So as Annapaola just introduced, from the original text like this, we processed it into sentences. So here you have the book, you know which book it's from, and the section number. Unfortunately for this book, we couldn't extract section number, but we do know which paragraphs it's in and which sentence it is. So this text looks much better than the previous one. You can actually work with it. How does it work? Okay. So once you have some kind of workable text, you can, of course, do the exact search. That's immediately possible. But you can also desire for some kind of semantic search because philosophical concepts are abstract. They often express in different ways in different parts of the book, and get the context is much more helpful for understanding what the author meant at the time. So for us, as OCLC has been tried to work with semantic embedding for a couple of years. First, I will give you some kind of foundation. Basic idea is if you want to know the word, you look at the context of the word. And then that will give you some kind of indication of what this word means. This is probably a bit abstract for you. This is a famous example of body work. Take a few seconds to read a few sentences of this. As a common person, and probably already guessed this is kind of a wine. So basically the idea is really for semantic embedding, trying to get the context. You study the context, find a way to represent the context to get what this word really means. So concretely, the word embedding for us is basically you represent the word as vectors of numbers. So here you have numbers to represent dog, cat, those animals. The most importantly is semantically similar words should be mapped to nearby points. So they are closer in this semantic space. By measuring how close they are in this semantic space, you can kind of guess how close they are in terms of meaning. So there are a lot of ways to embed, to try to get the word embedding. In OCLC, we developed our own method, is trying to use random projection for embedding. So here, basic idea is you have a C is a matrix. That's the only thing in math here. So you have a co-occurrence between all the entities because we work mainly with the bib records. So you have authors, citations, subjects. So we'll count how many things co-occur with each other. And you have a big matrix C there multiplied by a random matrix R. And then you end up with a C prime, which is much smaller representation of the original things you want to embed. After we process it in this Bolzano corpus, we embedded about 20,000 terms, words or phrases into as 256 dimensional vector. More importantly, we also embedded this more than 82,000 sentences we extracted from this 30-something books of Bolzano. And then the point is, so now the terms and sentences are all embedded in the same semantic space. So in this semantic space, we can calculate anything to anything. So giving me a term or concept, then we can find the most related sentences which Bolzano wrote about this concept. So that enables us enables the digital philosophers to look for, I have a concept in mind. Where in these 30-something books has Bolzano written about it? For us, of course, OCLC, we can do a lot with semantic embedding, immediately information retrieval, but more from library perspective, we can do disambiguation, deduplication, and helps matching different metadata in this DDD network, the problem there. But of course, we have a partner in this CatVis project. We want to see whether we can do something visually with this embedding. That's why I have to call Thom, because he is the expert in visualization.
Thank you. So my name is Thom Castermans. I'm with TU Eindhoven as a PhD student and involved in the CatVis project together with my supervisors. So as Shenghui already introduced, now we have this semantic space, and maybe if you didn't follow all of the details just now is the time to snap back in. So the important thing to remember here is we have similarities between concepts, and now we want to make that visible. Right. So this embedding is very abstract, so we want to make this more concrete. And we are going to do this by actually visualizing these distances or similarities. And I want to show you two ways of doing this, mostly to introduce the next part of our presentation. So first I want to discuss how visual cues work. And this is a very, very, very brief introduction into what visualization can do. So please bear with me. But the thing is, our visual system is very good at certain things. So if you look at these three figures, then I guess that all of you will see groups. So for example, in the leftmost figure, you don't just see a matrix of circles and squares, but you actually see columns of groups, because the human vision groups things that look alike. Similarly, in the middle figure, you will see these groups that share a region. And finally, and that's the thing that I want to use next, in the last picture, you will again see columns of dots because they are slightly closer together. So there's slightly more room horizontally than there is vertically, which is why you see groups. So now the idea is that we are going to use actual distances in 2D space to encode similarity between concepts. And now how do we do this? Well, we actually draw a dot for every concept. And if two dots are close together, then they are very similar. And now to give this slightly more structure, say that you search for a certain concept, then we put that concept in the center. So that's the sun of our solar system, which is why this is called solar view. And then the distances to the most related terms are then shown by these concentric circles around the sun. And these distances are as correct as they can be. And then we show all of the similarities between the other dots as well as we can. And this is a very technical thing, but you cannot get the distances exactly as they should be because this space is too small. That's what it boils down to. But yeah, I could talk about this for a very long time, but I want to skip to the next thing, namely the second way that you can visualize these embeddings is as a search interface. because that's very familiar to most users and also very easy to work with for, say, philosophers. So what we do is you search for a concept again, and there are some sentences or paragraphs that are most related to that concept. So in this interface, on the right, you see a tab, and that tab has the concept that you searched for, and you will just see a sorted list of most similar sentences or paragraphs below that. And if you do a couple of more searches, then you will just, you'll just get more tabs. So you will be able to quickly switch between what you searched for. And now there will also be some more information next to the search results. So this interface shows for everything that you searched for so far, how related it is to these search results. Those are the small vertical bars there, if you can see them. And on the left, all of the different works from, in this case, Bolzano are shown, and it shows there if the concept you searched for actually occurs in that particular work. And these components together make it very easy to, do the research that a philosopher might do. There are more requirements. There's more of a system behind this. I won't go into details here. For now, I just want to give the floor back to Annapaola to talk further about how she can use this system.
Thank you very much. Yes, I just want to show you, what we as philosophers can do with an interface like this. So how do we use the data that we have computationally, and how do we, use the tool BolVis that Thom introduced. We had a specific research question about Bolzano's position within the development of set theory. So set theory is nowadays like the common foundation for mainstream mathematics. And a big question for set theory was like, how do you develop the concept of number? And in particular, when you talk about infinite collections, like how do you count infinite things? So can you say, for example, there is a number to the collection of all natural numbers? And actually, human beings in general have two intuitions about concept of number. The one is the part-whole principle, who says that the whole is always bigger than a proper part of it. And the other is the principle of one-to-one correspondence, which says that sets of which the members can be put in one-to-one correspondence are of equal size. So according to the first principle, it should take, for example, the concept of all natural numbers and the concept of squares. Then the concept of the collection of natural numbers is bigger because there are more natural numbers than squares. Not every natural number is a square. But according to the second principle, these two collections are equally big, because for every natural number there is a square, because you can square it, and for every square you can take its root and you obtain a natural number again. So according to the second principle, the set of natural numbers and the set of squares are equally big. So these two principles are in conflict. And the second one is the principle that underlies set theory. So that is the one that has won, so to say, in mathematics. So Bolzano for a very long time reflected on these principles. He was also a mathematician. He's very famous also for his mathematical works. And the received view is that Bolzano never managed to see that he should have dropped the part-whole principle and just go for one-to-one correspondence, as later Cantor did. But a couple of weeks before his death, actually, he wrote this letter to a pupil of his who says, he writes about a particular passage in the Wissenschaftslehre and says the thing is not only presented unclearly, but also, as I just began to recognize, entirely false. So then we go to look like what is this this passage in the Wissenschaftslehre. So yeah, the details are not important here, but so the title of the section says no finite set of measures suffices to measure the width of all concepts. And then he's talking about the series in which the first term is like the collection of all natural numbers, the second, the collection of all squares, the third, the collection of all quadruples, so of fourth powers. And then he argues that like the first term is infinitely bigger than the second term, and the second term is infinitely bigger than the third term. So he's clearly arguing for the part-whole principle. So, but yeah, in order to interpret this section, to see what it actually means, so already the title for us, it's not completely clear what Bolzano meant there. So in German, it's keine endliche Menge von Maßen genügend, die Weiten aller Vorstellungen zu messen. And so there are some terms like Weiten, for example. Yeah, either we're not familiar with it or we're familiar with the meaning right now and the meaning might have changed. So we want to be sure what Bolzano actually meant with that. And that is what where BolVis comes in. So yeah, we make here a query for Weite, for the concept of width. And yeah, here we have the most relevant passages according to the calculations. And then we see on the left, because here are all the works of Bolzano which we have in our data set, and the ones with the gray dots are the ones where the concept Weite occurs in. And we can sort both by year and by relevance. So here we sorted by relevance, and we see immediately that there are only 4 books in which he used this term. So, but we also see that there are many irrelevant results. For example, when he's discussing a certain definition and he says, no, this is too broad a definition, yeah, then he's using Weite like in another sense. So that's not relevant for us. And actually, we managed to identify that there are only 2 books in which he uses the term in the relevant sense, and those are his mathematical books, so that makes sense. So we can filter out the irrelevant ones, because there is here this filter books option, so we select only the books that we are interested in. And then we find already the 10th result in the list, a very interesting result. And we go back, so from, oh no, you can't see it, but there are here some buttons from which you can go from the sentence, from the search result directly to the original text. So that's what we do. And there we obtain immediately like the definition of Weite, of width. And we see that so he means with width the quantity of the objects that the concept is referring to. That is the important thing. So again, back to the title, we now know what Weite means, but we don't know what messen is. So we repeat the same result, the same procedure, also to clarify what messen means. We can do some combined searches. So, for example, the concept of messen and the title of the section to restrict the results even more, to make the chance higher that we get something interesting. And then we find this sentence who says, like, in the meantime, it's also true that infinite sets cannot be measured. So it seems that Bolzano held that infinite sets cannot be measured, but that is okay. But yeah, in the passage that we started with, it seemed that he was measuring infinite sets. So how is that possible? So now we want to know, like, can we, according to Bolzano, measure infinite sets? So again, we make queries for sets and to measure, and for sets and to quantity. And so what we see is that in all those results, Bolzano says that you can compare infinite sets. You can say one is in some sense bigger than the other, but you cannot put a number on it. So you cannot really determine the number. But yeah, exactly. That seemed at least to be what Bolzano was doing in the passage that we started out with. So now we go back to that passage, which we understand a bit better now. And we see that he is arguing here that like the first term is infinitely bigger than the second and so forth, by taking every time a biggest number n, so bounding these collections from above. So in other words, like Bolzano is kind of measuring these infinite collections by making them finite. And then we go back, we now understand what he wrote in the letter to his pupil, where he says, like, the thing is not only presented unclearly, but also, as I just began to realize, entirely false. Because he continues, the false result was due to an unjust inference from a finite sense of numbers, namely to which do not succeed the number n to all of them. So yeah. To sum up, like, BolVis helped us like identify exactly what was the meaning of the letter that Bolzano wrote to his pupil. Okay, to sum up, so yeah, BolVis really facilitates close reading and conceptual analysis. So yeah, philosophy is not a thing that can ever be done like completely computationally. So we always will have to do conceptual analysis, so close reading of text. But yeah, a tool like BolVis really facilitates that. So it enables us to identify very quickly which are the relevant passages. And so yeah, it does that by returning the passages semantically similar to a given query, by allowing the user to order the query results and select from them in various manners. So yeah, select out like the works if we think they are irrelevant. And also very importantly, it allows the user to go back from the query results to the original text to see more context, to see, for example, whether an insertion was really from the philosopher itself or from the editor. Those are very important things for us. Okay, so yeah, the conclusion in general. So yeah, for our research practice, like open collections are not that open. And we philosophers have to ask like computer scientists, to solve our problems, to help us get the text that we want in a format that we want, which is also an expensive solution. And so what can be done? So yeah, we would like to have much more text openly accessible, of course. Also some standard data format. And yeah, have some data scientists think with us about how to organize all those data and things like that, because yeah, that is not our expertise, of course. Okay, thank you very much for your attention.
Thank you so much. Very interesting. The floor is yours for questions.